My name is Tessa Lev. I'm the marketing manager here at Artem Technologies. I'd like to take a moment just to thank everybody for joining us. I'll be controlling the slides, so Lance, whenever you want to hop on, I'll go ahead and take care of that. These are our partners over at ABQ Cabling. I'm going to go ahead and pass it off over to you, Lance.
Okay, great. How's everybody doing today? I would guess, okay, no, I don't see all your pictures, so you can just thumbs up. Yeah, let's see if I can. A joke, it's a joke. My name is Richard Lance Sloan. I go by Lance. I'm the chief engineer over at Albuquerque Cabling. I'm also a New Mexico low voltage contractor, licensed contractor here for the state. And I am RCDD as well, which is a big C term that gives me a fancy credential that allows me to certify plans and do engineering, make engineering decisions for low voltage systems. And so what I'd like to do in this presentation is talk a little bit about buildings and where we're at with technology as far as buildings are concerned with respect to cabling and fiber in the building. And we're just going to touch on that first, and then maybe possibly have another one of these that delves more in electronics, and what the electronics industry is, producing, that is the latest and greatest. And so it's of great concern when we're looking at our building, what kind of cabling choices we make and what kind of choices we make from an IT realm perspective. And so we're going to go through some of these slides. And as we go through the slides, if you have questions, please, you can stop me and we can talk about whatever your question is before we move on. And I realize there's going to be a whole bunch of acronyms and things here and that you probably haven't seen before that you might want to know about, and we can discuss that. But here she comes. We're going to change slides here to the next slide. So BICSI is this, it stands for Building Industry Consulting Service International. It's been around for a long time. It's been around since the 80s. BICSI's a professional organization for the advancement IT and communications now, because they're both really one. 26,000 members, and there's lots of credential holders. BICSI's kind of the cop that tries to help develop a standard with respect to building infrastructure and specifically ICT infrastructure. And what ICT is information and communications technology. What we're used to hearing in today's world is just IT, information technology, but because telephones got added to that with the addition of SIP and VoIP, we changed that information technology to be ICT, which is information communications technology. So it's interesting that these things they change as we go, and there's a lot of acronyms that are changing in the last couple of years that we've used forever. So it's ever evolving, and we just got to keep up with it. But BICSI's provided these credentialing programs worldwide now. They have shows in Florida and the East Coast and West Coast and overseas, Dubai, India, London. So BICSI is an international organization. It's headquartered in Florida, and I was a BICSI recruit a long time ago and started studying the whole low voltage thing. I was in the phone business and recognized that the phone business wasn't going anywhere, and it was going to, it's certainly going to be a market that I didn't want to be involved in anymore. And so I moved to the low voltage piece and started studying for what it takes to do that right. And BICSI is a part of that. And the reason I'm bringing these things up, they may sound like dull and drab, but this Bixby thing is the key to us getting this standard adopted across the country. There's really nobody that's going to be out there that's going to, push us along, except people like me that want to do it from an engineering perspective, want to try to, and we do a lot of design build work at Albuquerque Cabling. And so because of that, we design IT spaces and IT cabling to meet customers' needs and then install it, rather than have a list of parts and, a bunch of cable and a bunch of labor. So, again, stop me if there's any questions. Let's go to the next slide. And the Bixby credentials that are important, and again, this would be good for anybody that's trying to find somebody that knows about ICT infrastructure. Who would you want to pursue? Well, you'd want to certainly pursue somebody who has installer people under them that are Bixby certified as well, because just knowing how to build it doesn't mean you can build it. You got to be able to install it as well. And so the installer credentials are level 1, level 2, and technician. And then the design credentials are OSP for outside plant design. What that really means is connectivity with other buildings from the building you're in, campus environment connections, anything that goes outside of your roof space to another building. The DC-DC is the data center distribution credential. By the way, our internet wouldn't work like it did if there weren't for DC-DCs, because these guys are the guys that manage the big, terabyte connections between all the servers in the data centers. And they're the ones that develop the new technology along with the TIA and the EIA, in order to get standards ratified and accepted. And so the next one is this low voltage project management credential. I know that might sound like, wow, why do you need that just for low voltage? Well, because low voltage is different than any construction and all of these other things. And there's a lot more criteria that's necessary, metrics and things that are necessary to make sure that your low voltage installation is going well. And it's a very skilled position. But RTPM is a Bixby credential. That means you really know how to manage a project from a low voltage perspective. And then the pinnacle credential for Bixby is the RCDD. Again, stands for Registered Communications Distribution Designer. Next slide. Okay, so the RCDD, just to get through this real quick, it's the pinnacle designation in the ICT field, recognized by the ICT community and employers, required in bids and job requirements, mandatory on most DoD and DOE installations, uses the latest technologies, methods, and best practices, enhances credibility, recognized globally, and meets the highest standard. We have to work on our continuing education credits, and we have a 3-year sign-up period where we have to go through and learn a bunch of new technology as it changes. And then we have to get enough of those credits to re-up our RCDD, which happens every 3 years. So I just did mine this last year. Have to supply some drawings and do kind of explain what you're doing, and then meet the requirements for the credits. So that's really what it takes to really do ICT infrastructure design properly. It takes these Bixby credentials to, and again, because it's nationally and internationally recognized, it's something that's an important thing, to have somebody involved in that process when you're trying to build a building, or you're trying to like revamp your building so that you want it to be the latest and greatest technology. And we'll talk about that in a minute in some slides that suggest why this needs to be a real important thing going forward. The speeds, I don't know if anybody's noticed that the speeds of everything is increasing, and it's increasing dramatically. And we got ourselves in a pigeonhole in the world here, and especially here in New Mexico, because we don't even recognize Bixby much in New Mexico. In other states, It's never even thought about, are you going to include an RCDD in the architect consultant group? Because yes is the answer in all cases. And here, we kind of don't do that. We use an approach that involves an electrical specialty person who draws this plan called an ES plan. And he sticks that in the drawing set with the architect. And the problem with that is it doesn't really give us, there's no knowledge there to really do that design well. So what you end up with is a bunch of conduit and a bunch of triangles on a drawing showing where you want cable installed. And it doesn't really give it justice at all. And the problem with that is when you come in as an RCDD with those specialty drawings, there's some decisions that are already made, like for example, the IT space. Where the cable is going to go down the hallway. All of these things are all drawn on this by a guy who doesn't, he knows conduit, but he doesn't know anything else, and it's a real trouble. So that's the way we do it here. In other states, obviously, and DOD and DOE, which I'm familiar with, it's mandatory. So when I see a drawing that's coming for Kirtland Air Force Base, for example, I look at it and it's got an RCDD stamp on it, which we have, just like a professional engineer. We can stamp plans to approve them for the city, for anything. What we see is the professional engineer that's in charge of the whole group that puts a stamp on this electrical specialty sheet. Doesn't even know, what he's stamping. So what I'm trying to do is change that. And we're trying to do that by meeting with architects and things and trying to get involved in the beginning of the process rather than in the middle, and or worse than that, at the end. And believe it or not, schools and everything, nobody's immune from it. I have had some messes with schools trying to fix them because everybody then starts the finger pointing because there's no money set up to do the things that I've just come up with that you need. And so that's why it's important to engage an RCDD in the beginning of your process for your building or your relocation or whatever you want to do, maybe possibly, just upgrading your building to the latest and greatest. And we'll talk about here in a few slides here why that's important. Go ahead, next slide. Okay, I wanted to share a little bit about what a standard is. Most of us think, oh, it's a standard, it's something we follow. Well, okay, so where'd that come from? Well, whoops.
Sorry.
That's right. A standard originated from a battle flag that served as a unifying symbol for all participants in combat. So the standard was this, flag that they held up, typically with two poles, and it was square, and everybody could see it from behind you, and they all, single file line, like the mice followed the flute player with the standard. And so that's kind of how the word evolved. And because of that, I'd like to, just share that without standards, on a lot of things, we'd be in big trouble. And unfortunately, on the IT side, because the owner typically has to pay for those things and they're not included in the construction budget, it's what's created this problem with the plan set and the architects. And so what I'm saying is we need to there is a standard out there for ICT infrastructure. It's been around forever. And the problem is nobody follows it. And it's just due to lack of knowledge. And what I want to do is make sure you understand that going forward to keep your building up to meet the needs of the new technology. The biggest thing to do in that is to meet this standard. So following standards offer numerous benefits: enhance consistency, improve quality, reduce cost, increase safety. Standards provide a framework for achieving economies, efficiencies, and interoperability, which, again, interoperability is very important in today's world because everybody's got an app they want to use, and we want it to all work together. They also help to establish clear expectations and ensure that products and services meet minimum requirements. So again, standard is something that we can't avoid. We have to open our eyes to the fact that there is a standard for ICT infrastructure and then start following it. And So this is just kind of a thing that's out there, but there's really no laws or no legislation that, that makes this come to light for everybody and forces them to do that. And so because of that, and it's not standard, it's not really a code, it's more of principles and practices so that we can get on the same page with installing technology cabling. So go ahead, next slide. Okay, so this ANSI TIA 568E standard for ICT thing's been around a long time. I would hope that everybody is familiar with the American National Standards Institute. We probably should all be familiar with ANSI. And ANSI is also part of this 568E standard. And the Telecommunications Industries Association and the Electronics Industries Association went together back in the early 90s and developed these standards. And they're really important. And most people don't know what they are or what they're about. And I'm not going to spend the time to go through each one of these things and explain what they are because it's boring stuff. However, what I do want to do is show you the quandary that we're in and how we can work to get past that. Knowledge is the key. But the generic telecommunications cabling for customer premises is just 568.0. And that, by the way, you can get a copy of the 568E standard from the Telecommunications Industry Association website. If you want to write that down for later, you can do so. But the .1 is the commercial building telecommunications infrastructure standard. The generic one kind of lays out a little bit about how IT rooms should be and whether they should be locked doors, how much space is required. All of those things are built into this standard so that it's real simple to sell to the higher ups that, look, we're trying to follow this standard and we want you guys to know what the standard is so that we can we can get something that will go forward and gets us to the latest and greatest. 568.1 lays out the infrastructure standard for a commercial building. And there's basic design considerations for space and how many people can occupy a given space. And believe it or not, it's 3.28 feet, which is 1 meter square is what they see as a workspace. I don't know how many people could live in that space. I certainly couldn't. However, when you go to calculate, cables required for folks to use the network, that's what they use as a judge. They take out the common areas, elevators, and those things, and then use the leftover space and divide it by 3.28, and that's how many squared, and that tells them how many workstations they potentially could put in that space. And so we do have some, basic, if you don't know what's going in the building, we can give you some basic ideas about how many cables it takes to support those people. And again, a workstation is 3.28 squared, and it takes two category cables, whatever level you choose to operate one of those or to have one of those spaces set up for network cabling. And obviously there's variants of that because people might need more things. However, that's kind of the default, is a dual location, two locations, one for printer, one for the computer itself. Now the .2 piece is, it explains how the balanced twisty pair cabling works. And there's a standard for that. And when we say balanced, what we mean is the two wires look the same. Okay. So when we say balanced and unbalanced, balance means that a cable pair of wires, like in a Cat6 cable, for example, both of the wires are the same. That's called a balanced signal. On a coax, piece of coax, like you would have for your TV or Comcast or anything, that's an unbalanced cable. Why? Well, because the two conductors that are carrying the signal, the center one and the shield on the outside, are different. And so because they're different, that's called an unbalanced connection. There's different rules for unbalanced connections. So that's the difference between the two. The .3 is the optical fiber cabling component standard, which is really deep these days. And that's because fiber has changed so much recently. Again, speed of the internet's driving that. Number 4 is the broadband coaxial cabling, and again, that's discussing how a coax cable works and what. Again, it's an unbalanced connection, and we're kind of moving away from using coax, and there are some things that it works well for, like a distributed antenna system, where we want to try to boost the cell service inside a building. We would use a coax cable for the antenna, and the reason is because it's low loss. Means that the energy required to send a signal over coax is much less than it is on a balanced connection, and therefore we can run it longer distances, and it works great for antennas. So that antenna service that you're trying to replicate in the building, you want to make sure it's strong. And the best way to do that is to do it with a coax cable. So there are some things that aren't fixed in stone here with respect to coax. We are using it in some cases where it best fits. But the speed limitations of broadband over coax are pretty much passed. Everybody's looking at fiber-based internet access, and the problem is the internet's faster than our little computers are now. And that wasn't the case, but it is now. So the .5 balanced single twisted pair communication components. That was the single twisted pair telecommunications cabling component standard was when phones were different than computers. And there was a long time in the 90s there where a telephone connection was not IP. And because it's IP now, it follows a different standard. So again, if you want to take a look at that, you can get it off the TIA website. It is it's fairly robust. There's a lot to it. It's definitely sleeping material. But if you want to find a particular thing and make sure you're meeting that requirement, it's real easy to look it up and see. So if you want to go to the next slide. So future-proofing your building. Future-proofing your building has kind of 3 things that really stick out. One is the structured cabling system, meaning you're using a cable system that's been developed by a manufacturer that meets all the criteria of the 568E standard, and also makes it, it makes it very scalable because you can add to it easily. And there's a management technique for it, for administration and everything. And so when you say structured cabling system, we're talking about a complete system. And it's just wire from A to B. Yes, it is. However, it meets certain criteria, the way it's installed, the way it's tested, the way it's certified. I don't know if people realize, but Cat 6 has to be certified to run at the speed that you're going to run it at. And most people don't, they just get the maintenance guy to run the cable. And first of all, it's not legal to do that because the city of Albuquerque says you have to have a low voltage contractor's license to run cable in your ceiling. Most people don't know that. But testing it and certifying it at a given speed is also should also be a requirement. But very few people do that. When we install something, a cable system, an ICT structured cable system, we follow most of these rules. Some of them are stupid. We don't follow the stupid ones. We follow the smart ones. And providing a certified cable plant and test results to the customer is paramount for the end of the project. And also having an as-built drawing that's developed in Visio or CAD or one of those automated drawing programs so that we can go back and look at what we did. And then we can change it and keep it up to speed. And so a lot of our customers have, a 3-ring binder that has, all their floor plans and all of their outlets and everything drawn with a number plan that makes sense. and with labels that match what's on the drawing. And labels that match what's in the phone room. There's standards for all of that. We try to adhere to the ones, again, that are real important to the customer. Again, this high-speed data rate thing needs to be underlined because, again, today, we're quickly approaching the gigabit not being fast enough to computers. It's just not fast enough to take on the new internet connections that we're seeing coming out right now, especially with Starlink and some of these others. Mike just got his Easy Fiber connection at his house. He's a salesman back here for me. And he did a 1.2 gigabit speed at his house, which is really cool. Problem is, this computer isn't fast enough to take advantage of it. So if you got a gigabit feeding your router and you got a speed above the next capability in the network interface card in the computer, it's not going to work that fast. And so this is kind of why this future proofing your building is really important right now. Okay, it's really important right now for a number of reasons. One is, as you add technology and speed, you have to marry the right cable to that, or you're not going to be able to continue to operate in this world. It's going to smoke you. You're going to end up with computers that won't work fast. They just sit there and spin the little hourglass. So it's a big issue. So implementing speeds that can support future high-speed data transfer demands, such as Cat6, and really Cat6 is really, a lot of people say, well, we got Cat6, and if you're talking about Cat5 and Cat5e, you need to forget that, because that, first of all, Cat5e uses all 4 wires to develop a way to do a gigabit, and there's no headroom in it at all. So Cat5s, we shouldn't even be talking about that, and really Cat6 is something that is really a minimum. And when I say a minimum, if I was building a new building, it wouldn't be with Cat6. And the reason is Cat6A, which is augmented Cat6, is a 10 gigabit wire, and we should be running 10 gigabit wires in new buildings now. And certainly need to do it for all of the wireless access points, because Wi-Fi 6 and Wi-Fi 7, the new technologies that came out for wireless, won't even, they can't use a 1 gigabit pipe anymore, especially the MIMO ones, which stands for multiple input, multiple output. They need a 10 gigabit connection to share. Why? Because there's more than one person using it. And so what I'm saying is that Cat6A is more the right approach for desktop cabling, and certainly from a perspective of wireless surveillance, same thing. The scalability and flexibility, we talked about that, how easy it is to add to it once you meet the standard, because not only is it going to give you a really cool convention for numbering your cable locations, you'll be able to find them easily and make patch panel changes. I know people that have patch assemblies where they have wads of patch cords that you couldn't even trace one out if you tried because of the mess. It's just a mess. And there's a right way and a wrong way to put patch cords in a rack. And unfortunately, people don't give it, they don't spend the time making that important. It needs to be important. And for a lot of reasons. One is it makes it easy to add and change, and instead of digging through a pile of patch cords and you don't even know where they go, you don't take the left in ones out, meaning they're not used anymore, remove those. So it takes a little bit of maintenance to keep this going. But again, it was designed well, and if we just follow the structured approach, especially with the patch cord piece, then everything goes well. Scalability and flexibility. So accommodating future growth, it's real easy to snap in new inserts and run new cable. If you put a wire tray that's correct in the ceiling, you should have plenty of space to add to it. And by the way, there is standards for how the cable needs to be run in the ceiling, not only from the city of Albuquerque's perspective, but also from from a BICSI and a National Electric Code standard, we should support it every 5 feet. It should be self-supporting. It can't be tied to the grid in the ceiling. It can't be tied to the ceiling grid wire in the ceiling. It needs to have its own cable tray or its own supporting hardware every 5 feet. And, when we're doing a new building, if we don't meet those criteria, then the city of Albuquerque doesn't want to give us a green tag saying that you passed, right? They want to see everything clearly marked. They want to see, going through walls properly with the sleeve that's fire caulked. And there's all rules for fire caulking, conduits and things. So low voltage doesn't require conduit. However, it requires a really good cable path and a fire protection system and all of that. And those are the things that, people don't understand. Oh, well, I'll just get the maintenance guy and lift the ceiling tile and throw the cable in there, and then all the cable's laying on the ceiling tiles. And you can't lift the tiles anymore because there's 200 pounds of cable on screens. Guys, it's not supposed to be that way. So, do we have a question? Nope. Okay. Next slide. Okay, this is a real important slide. And I want everybody to catch a gander at some of these dates. 10 base T, it means 10 megabits, and base T means it works on twisted pair cable. Meaning we went back to that. That's the balanced cable that we talked about, Cat 6, Cat 5e. 10 base T was Cat 3 provided technology, and it was in 1990 that we used that. And you could do it over fiber and you could do it over copper, but 10 base T is really the standard. And the category cable that was developed to carry that speed was Cat 3. I'm dating myself. That's a long time ago, but that's what we installed. Lots of Cat 3. Before that, we did coax over for LANs. Okay, we did an unbalanced solution. And it was really bad because we had to run a cable to a jack and then to another jack and into another, and we had to do it in series. When troubleshooting, it was difficult. And then the 100 base T or fast Ethernet, we're laughing at that, standard was developed or established in 1995. So Cat 5, guys, was developed in 1995. So when people say a Cat 5 cable will work, we need to erase that from our minds, because Cat 5 cable was really designed to just support 100 megabits, and anything over that, you're trying to do gigabit with it. The only thing that you can't do gigabit with it, you can do 100 base T, and that's it. And again, this is under the standard, so it's 300 feet, 328 feet to be exact, or 100 meters is the distance. So in 1995, we were doing 100 base T. Now, 1,000 base T, which is what most people are using today, which is gigabit speeds to your computer device or all of the other IP-based devices, which, again, there's a plethora of those things now. Everything's IP-based, right? So because of that, and the IoT, the Internet of Things, is driving us to, get the speed up, and the internet companies providing the speed for the internet has really increased dramatically over the past 4 or 5 years to where our speeds now are lacking. It used to be the opposite of that. We just couldn't get an internet connection fast enough to support everybody using it. Now that's not the case. Now we've got a speed that 1.2 gigabits at a house. And there are lots of people with 10 gigabit, 100 gigabit internet connections, terabyte internet connections. And so how do you take advantage of that when you got a footprint that's just a gigabit out to the desktop? And the answer to the question is you don't. Wireless technologies with Wi-Fi 6 and 7, if you're using wireless, 300 megs is about the best you're going to do unless you have a multiple antenna wireless solution that combines 300 megabits each. So the problem now is the fact that 1999 is when we started putting in Cat 5e. It really should be looked at as a legacy speed and a legacy cable, and we shouldn't be installing any of that. Yes, you can still buy it. You can still buy Cat 3 if you want. Which we do in some telecommunications applications. But okay, so the next speed then was this 10 G-base-T, 10 gigabit Ethernet standard. It's been around since 2006, right? And nobody's even using it between their telco rooms, their IT closets, let alone out to the desktop. But 10 gigabits we should be looking to deploy 10 gigabits to the desktop now. Why is that? Because the link speeds for connections between closets now need to be 25 or 40 gigs, or even 100, based on what your plan is for your building, and what applications. Obviously, it's application driven. What your applications are going to be, and so this is just an eye opener when you look at the dates that these things came out, and the fact that we're not even, we're still in a 2000 technology. Cat 6 came out for the 10 gigabit standard, and the problem is that the implementation of it didn't support 10 gigabits because of this thing called alien crosstalk. And if anybody wants to talk about that later, there's some marketing things in there that really changed the world. But what happened was they deployed this 10 gigabit standard over this kind of cable, and they did a ton of installations and certified it. And then they found out if they bundled more than 50 of the cables together, it created this weird alien, frequency. Because that, when you're talking about 10 gigabits, you're talking about voodoo. It's really fast, okay? So what happened was one cable impeded on the other cable and caused this brand new thing called alien crosstalk. Guess what? Cat 6 didn't work for 10 gigabits. They had to recall the whole standard and everything. And then the manufacturers are like, listen, we're lost, dude. So consequently, it led to the development of Cat 6A, and that stands for augmented. So now we're in this thing called gigabit Cat 6A, or I'm sorry, multiple gigabit speeds, in this case 10 gigs. And we're talking about Cat 6A augmented. And the first one that came out had this big, huge wire that was a ground around the outside of the jacket, and you couldn't install it because it wasn't round. And so then they went back and they did some more development, and they came out with one that doesn't take a ground wire on the outside, but it has this plastic liner inside now that keeps all the pairs separated, and that alien crosstalk went away. But it's important that Cat 6A is the choice. Cat 6 is only rated at 100 meters for gigabit speed. So that's the problem with it. Most people think, oh yeah, Cat 6 will run 10 gigs, and it will, up to a certain length. The problem is it doesn't meet the standard for length. The length is 300 feet, right? The cable itself should be 300 feet, and then that leaves you, the 28 feet for patch cords. So it's really that critical. It needs to be, and then it needs to be certified as well to make sure you're running at that speed. Now, multiple gigabit is come out 2016. So we're going 25 and 40 gigabits in 2016, and we're doing it with Cat 8 cable. Cat 7 died, and everybody's asking me, well, what happened to Cat 1 and Cat 2? And a lot of these died in their concept because there really wasn't an Ethernet standard to marry it with. Okay, so because of that, the 25 and 40 base T multi-gigabit standard was established in 2016, and the Cat 8 cable is the one that met that requirement. And so you can run 25 or 40, which is multiple gigabit, up to 300 feet with a Cat 8 cable. So far, I'm not recommending Cat 8 cable. I'm recommending that people consider, single mode fiber instead of that, and in my case, I don't do much multi-mode fiber anymore, and I'll share with you why we don't do that, but if you look at the last line here, a 1.2 terabyte Ethernet standard is currently under development and will likely be a fiber offering only. And again, we're reaching the limit of copper working. Because again, you got to turn the voltage on and off, and you got to be able to detect it at billions of bits per second. And that's a difficult process. The faster that gets, the weirder it gets. And terabyte Ethernet is a really, really fast thing that's being developed. And again, they're working it right now. It could be standardized in the next few years. Not that anybody's going to be jumping up and down to go get it, because again, we got to stay ahead of the applications and the speeds required. But 40 gigabits is very normal. 100 gigabits is very normal. And again, when you get into multiple gigabits, there's lots of choices there that you can go to. Next slide. The speeds of Ethernet are shaped regularly and dictated by the needs of the application supported. So again, Ethernet is great if you're doing a hosted app. Your internet speed is critical, but your LAN speed is critical, because if you want to take advantage of the hosted app and you want it to work well, you need a speed to your desktop that's faster than the internet connection for sure. And in most cases, people don't have that anymore. So they've got residual bandwidth that they're not using because, yes, it's shared, but when you look at it, one person can't occupy the whole speed of the internet, which is not smart. It should be, we have a fat pipe going to the computer so that they can use the fat pipe coming in from the world. Today, most applications are hosted or sourced by the internet. And back in the day, when I was putting Cat 5 and Cat 5e in, we had server-based technology and everything was there locally. Okay. And so, the speed between the computer and the server was not the weakest link. The weakest link was the fact that the server couldn't compute fast enough to get things out to the desktops. And so nobody cared about the cable. That's the opposite of what we have now. What we have now is we want to take advantage of that fast pipe. So how do we do that? And the way we do that is keeping our speed to the desktop as fast as we possibly can, within reason. I'm not suggesting anybody go run out and buy a bunch of Cat 8 and install that, because that's I think that's overkill. You got to be smart about these things. I think Cat 6a is a great choice we install lots of Cat 6a, and do all of the due diligence that meets the 568 standards with that speed cable. So internet speeds available today are multi-gigabit or approaching multi-gigabit. Again, with Starlink and those, you can get a terabyte connection if you want. So again, building the local area network fast enough to meet these needs is something that you have to consider. Ethernet speeds for desktop computers are typically determined through the network interface card, as well as the speed of the switches that the PCs are connected to in the server room. So again, the NIC card in most people's laptops right now currently is a gigabit. Guess what? That's changing. And here's how I know it's changing. When you go to order a Dell computer, it used to be that you could choose an option for your speed of your Ethernet NIC connection. And now they default it to 1 gigabit, but 10's right under it. And so as soon as that becomes the default shipping speed for a NIC, the Cat 6a market's going to go through the roof. And that's because, and they're not far from doing that. You can buy a 10 gig NIC for just a few bucks more than you can get the regular gigabit NIC. So as soon as that and the reason I know this is because that's what happened with 100 base T. When 100 base T came out, the first thing that drove us to gigabit was the first computer that came out as a default cost had a gigabit NIC in it. And as soon as that came out, everybody wanted to replace their Cat 3 with Cat 5E or 6. 6 wasn't out yet, but 5E. So I can see the same thing happening right now. And as soon as the PC manufacturers start selling those machines, and yes, they're going to use wireless technology, and yes, getting more than 300 megabits to your computer to use in a wireless environment requires the configuration of the wireless access point so that it can multiply the 4 various antennas into one stream for you so that you can go faster than 300 megs on wireless. So a lot of wired connections are going to work way faster than Wi-Fi 6 or 7. So next slide. Running out of time.
Yeah, we're over time, but
Oh, we're over. Ethernet switching and network interface cards are currently undergoing significant changes. I just kind of talked about this. Buying a 10 gig switch is a very common thing now. You can get 10 gigs. You can buy a fiber switch that has SFPs that you can put in, gigabit speed, 10 gigabit speed NICs or SFPs that support fiber. The speed of the local area network is lagging behind because of the internet deliverables. And so Cat 6A or Cat 6.8 is really the choice. Ad-block software has added latency. Raise your hand if you think that's crazy. It's crazy what ad-block does to your machine. Takes it to its knees, right? And so all of these things just add to the fact that you need more speed going to your machines. And I'm hoping that that's what we're gleaning from this presentation. Next slide. Fiber optic connectivity is undergoing the same speed challenges as copper. Fiber is used to connect ICT infrastructure rooms together. There's 2 types of fiber. We could spend a whole session on just fiber, right? But for most of you, single mode and multi-mode. Multi-mode uses LEDs to send data. It used to be a lot cheaper alternative because of the transceivers that you use in the switches. Single mode uses a laser. And so that's why the transceivers were really expensive for single mode. Not the case anymore. Okay. The problem with multi-mode is look how many of them there are. Multi-mode has changed every time a new speed is developed. We've got 100 gigabits at a reasonable distance. You got OM1, OM2, OM3, OM4, and OM5. And when the speed goes up again, there will be an OM6. What I'm saying is, can it? We don't need it. Why? The only reason we were using multi-mode was because the transceiver cost, because due to LEDs, was much cheaper than single mode. The single mode transceivers were just way out of whack on price, right? Because they were lasers. That's not the case anymore. They're nearly the same price. So with that said, we recommend single mode everywhere, not just outside plant because it's a long distance, not just between buildings because it's a long distance, but we recommend it between closets now, because guess what? There's really no speed limitation for single mode fiber. And the reason there isn't is because we have this thing called DWDM, wave division multiplexing, which puts a prism in front of each laser and then turns off the different colors of light and multiplexes fiber. And because of that, we're able to, quadruple the speed. And then we just use more fiber strands to make the connection faster. So single mode's the best choice. Go ahead. Okay, so the procedure for future proofing your building, trying to wrap it up here. Obtain expert design assistance. Reach out to your Artem salesperson for support. Complimentary design help is readily available. We'd love to help you with, designing your building. Hopefully we can get in there before somebody who doesn't know what they're doing, alters it. That's why it's important to engage the architect. We meet with architects all the time. We're trying to, to get there with those guys. It's a difficult nut to crack. Follow the TIA 568D or E standard. If you don't follow it, at least the things that are important, you're not going to get where you need to be. And you also need to install it per that and make sure you're using an installer that knows how to put it in and knows how to navigate the licensing and the permit to install the cable. You're supposed to have a permit from the city of Albuquerque when you alter more than 5 cables. Most people don't know that. And so in order to get a permit to do that, you gotta go to the city and you gotta find somebody that's a low voltage contractor. Choose single mode fiber for all connections other than IT rooms or 2 other IT rooms and server rooms and outside buildings. Choose Cat6 as a minimum for all IP-based devices. How many are there out there? Well, now everything is IP-based, right? Dedicate enough space for IT server or equipment rooms correctly. Nobody does this right. This is a bomb. Why? Because the architect wants to take every square foot and turn it into something other than IP. And you almost have to fight for it. You won't believe what I've done just to get a room closet. And no, there can't be water in the room. There can't be, a mop rinse out, or anything like that in there. Believe me, there's server rooms inside of places that have sprinklers, which is crazy. You can get enough heat in that server room to trip that guy, believe it or not. Dedicate enough space. So again, this IT server room thing is real important. And when planning a new building, it's advisable to involve an RCDD if you can at the onset of the design phase, to ensure that you're meeting at least the things that are important in the standard. So I think that's the last slide.
That's it.
Yeah, so with that said, is there any questions that anybody has about anything I've said? Please, you can email me. You can, if you don't have my email, it's real simple. It's lance@albuquerquecabling.com, all spelled out. I'd be happy to answer your questions. You can have a copy of the slides. You can do whatever you need. I guess we'll leave it open for questions if there is any.
Yeah, if anybody's got any questions, feel free to just go ahead and drop them in the Q&A or in the chat. We'll take them. But as Lance said as well, reach out to your Artem team member who you work with, and you can get your complimentary consultation scheduled, and you can look at if you're looking to, move into a new building, build a new building, expand, upgrade your current cabling, anything that you've got going on. If you're looking at speed capabilities, we'd love to have a chat and discuss how we can help